Welcome, good to see you. Welcome to Unit 3, Lesson 9. So you're looking for the tasks for U3L9. You can find it under assignments or on the weekly calendar on the campus homepage. Today's date is December 10th. We'll start off with our usual chat room share. Question for today is, what's your favorite family tradition? You guys haven't answered this one before yet, have you? No? Okay. I'm trying to keep track, but I lose my place sometimes. So this could be broad, right? What's your favorite family tradition? It could be something you do every week, like what's a Friday night thing you do or something like that. It could be a way that you celebrate members of your family, like a special birthday thing, or like a way you celebrate your pets or something like that. It could be a religious or holiday thing, right? Like Christmas or Halloween or New Year's, whatever you feel like sharing. Think about that for 20 seconds. And don't forget to say hi and check in. Thanks so much for sharing. Next on the docket is just checking homework, which is looking good. You just had to make sure you wrapped up that classwork we were working on about the Can Crush, which involved 2 ed puzzles. Again, I'm seeing 13 attempts on that, which is good. And then the homework was another ed puzzle with some quiz questions associated with it. Again, I'm seeing 11 attempts on that. I think the big takeaway from this graph is just getting at Boyle's law and the idea of an inverse relationship, right? So as volume of a gas goes up, pressure of a gas goes down, or vice versa. That curve in that graph is a classic example of an inverse relationship with their opposites. And again, ed puzzle's looking good. Remember, there is the alternative Google form you can also complete. Any questions or comments on the Can Crush or the homework assignment on Boyle's law? Our goal today is to review Boyle's law and then get into the next 2, which is Charles's law and Gay-Lussac's law. But before we do that, let's use a Kahoot to see how you're feeling about Boyle's law, unit conversion, and general gas properties. Okay, the join code is 5735875. As usual, please use your name or something close to it so we know who everybody is. Start the game since most people are here, but again, the join code is always in the lower upper part of the screen. You can usually see it. All right, 8 questions. Let's do this. Gases are blank, meaning their volume can be decreased under pressure. Very good. Pretty much all of you got that. That means compressible. We can shrink their volume down. Yeah, not expandable. Expandable is the opposite way, though I guess you could argue that gases are also expandable. But what I was getting at with decreased volume is compressible. Wiley in the lead. Here we go. Kilopascals, atmospheres, and millimeters of mercury are all units of what? Very good. Most of you got that it is pressure. It's not volume. Volume is usually liters or milliliters. You'll always use that for volume. But yeah, kilopascals, atmospheres, pounds per square inch. There's a bunch of different measurements for pressure. All right, Wiley's still holding his lead. Increasing the kinetic energy of gas particles, making them move faster, means you did what? Very good. You all most mostly got that it is increase the temperature. Remember, temperature is a measure of average kinetic energy. So if you're increasing that kinetic energy, you're increasing the temperature. A lot of you went with decrease the pressure. It would actually have the opposite effect. If you were to speed up the movement of gas particles, you would actually be increasing the pressure, not decreasing it. All right, Quinn pulling in the lead now. Okay, true false question. If you increase the pressure on a gas, its volume will also increase. Nice, that was fast. Very good. You all got that it's false. Remember, it is an inverse relationship. Pressure goes up and volume would actually go down, wouldn't increase here. All right, Quinn still in the lead. Which law states that at constant temperature, gas pressure is inversely proportional to gas volume? So which law was the law you were just proving false in the previous question? Nicely done. Everyone got that it is Boyle's law. We'll talk about Charles and Gay-Lussac's law today. Anyone know what Murphy's law is?
Yeah, isn't that like everything bad that can happen will happen or something like that?
Yes, anything that can go wrong will go wrong. All right, Wiley's on fire, but Quinn's still in the lead. Bob Gardner's air balloon was small when he left the ground and really big at 39,000 feet. Why? Why did his balloon get larger? All right, we're a little torn on this one. So it looks like a lot of people think increased atmospheric pressure increased the balloon volume. Again, remember, it's an inverse relationship. His balloon, the volume got larger, therefore the atmospheric pressure actually decreased, right? There's less atmospheric pressure as you get higher and higher up. And so we noted it a little bit in the video, right? But the balloon really didn't look that impressive when he first took off. But then when he got up to the point where he was going to jump, the balloon was absolutely enormous because there was less atmospheric pressure. And therefore, even though it was the same amount of gas, same volume of gas, inside the balloon, it expanded to a much larger volume. Okay, Quinn's still in the lead. Here we go. Second to last question, true, false. In the equation, P1V1 equals P2V2, P1 and V1 can be any unit as long as they match. Nicely done. Boy, you guys are fast. Yes. As long as they're the same unit, they could be kilopascals or atmospheres or whatever. All right, this is it. Last question. Gas pressure and gas volume are inversely proportional. If you double the pressure on a gas, then what happens to the volume? Very good. Most of you got that it is reduced by half. Again, you got to put your math hats on a little bit there, right? Because if you double the pressure, that means you did times 2, and it's an inverse relationship, so then volume would be divided by 2 or reduced by half. Done Quinn, Alex, and Wiley with Emily and Angel and 4th and 5th. All right, it looks like most of you, again, got most of those questions correct. So awesome performance there. Okay, any questions or comments on that Kahoot? Okay, next up, as you can see on the tasks to complete list, I basically have lined up 3 ed puzzles. One on Boyle's law and unit conversion as review, the second one on Charles' law, and the third one on Gay-Lussac's law. They have questions in them that are going to give you some practice, so you're going to need a calculator. So I'm fine if you want to use your phone or use your computer, whatever you need to do, that's fine, but you're going to be doing a little bit of math. So I'm going to time 10 minutes for each. And once it looks like most people have gotten through the ed puzzle, or we'll just come to a pause point after 10 minutes, and then I'll show you a little kind of real world application video and then give you time to move on to the next thing. So we'll start off with 10 minutes to work on the first one, which on the tasks to complete list is step number 3, Boyle's law ed puzzle. This one's about 7 minutes long with 3 questions. 10 minutes to work on Boyle's law ed puzzle, go for it. And I'll also say that if you finish one of the ed puzzles and there's still time, you're welcome to move on to the next one if you want to.